Okay, in preparation of drawing our snake segments, I want to create some homogeny. I want to tweak snakehead a little bit so that it functions like one of the segments of the snake instead of being all special. And the biggest problem I have is the fact that we have its x direction and y direction as globals. Then we use an entirely arbitrary direction indicator that's supposed to be used to render a sprite that we're now using for game logic. That's not a great idea. So we're actually going to revert the changes from our previous video. Instead of having dir new as our special fancy direction, we're going to make dir new x and dir new y. And we're going to start the game moving up, which is the y-axis, negative. Then eventually all our snake segments are going to have an x direction and a y direction, so we're going to rip this out, and instead of having a direction, we're going to have x direction and y direction. Again, we start by moving up. Okay, then we are still going to need that fancy arbitrary direction when we draw the sprite. So instead of calculating it at draw time every time, we're just going to look at these values and pass back the one we want. So because snakehead is an object, it's a table because Lua, but it can have members. It can have a function inside it that references its own values. So snakehead dot get direction is going to have a reference to itself. I'll explain this in a second. It is a function, right? In languages like Python and I think JavaScript, you have the ability to call a function inside an object and have a reference to the object it's being called on. So if you have multiple snakeheads, they can each have the same function called getDir for getDirection, and each one will only look at itself instead of looking at the global namespace and getting confused and having to find the right one in an array of stuff. So these values are mutually exclusive. If we have an x direction, we do not have a y direction, which means if self dot, which we know is now snakehead, y direction is equal to -1, it means we're going up, so then return 0. I'm just doing these inline because it'll be nice and neat by the time we're done. Okay, if self dot, if we want to go to the right, then x direction is equal to 1, then return 1, which is 90 degrees clockwise. Else if self dot y direction is equal to 1, then we are going down, so that'll be 2, and also if self dot x direction is equal to -1, then we're moving left, which means we return 3. So these values are what our x and y values will be for the direction we're moving in. And in this outputs, if we're going up 0, to the right a single 90-degree turn, then 2 90-degree turns pointing it down, and then 3 90 degrees, so 270 pointing to the left. So this little function does the work of translating these coordinates to which sprite we're going to render for the head. I also have some ideas of making the head piece much smaller, and then when we render body segments for the snake, we also render the head as a body segment and stick the face on top of it so that it looks like the head of the snake, but we'll worry about that later. Okay, next up, we need to rewrite our inputs because dir new no longer exists. We have dir new x and dir new y, but every time we press a button, say for instance we're pressing 0, that's up, we are setting the y direction, but we are unsetting the x direction, which means in this function we'll essentially be writing the same code over and over and over. If we set one, we unset the other one back and forth. So I'm going to introduce a little function somewhere right here below inputs, and we're going to call this new direction. It's going to take an X direction and a Y direction. The reason we can use the same variable names here as we do in other places is because these are parameters being received by the function, so they are local to the function, and then we're setting something to that. If these were named something else, like A and B, and I call xdir, first Lua will look for this variable name as a passed parameter. Actually, first it'll look for a local variable called xdir. If this doesn't exist, it checks whether xdir was passed as a parameter. If that doesn't exist, it looks on the global namespace. So by putting these names in here, even if there is a global function by that name, we don't have to worry about it. Oops. We don't have to worry about it overriding this value, because these will be seen first. So X direction. What do we need to do with X direction? We need to set dir new X to that value. Then dir new Y to Y dir. Okay, so when we call this function, we pass two variables, or two values, and one of them will always be 0. But because we are forced to call both when we call this function, we know that they will both be set. So if button 0 is pressed, which means we're moving up, we call our brand spanking new function called newdir, and we send it for up an X of 0 and a Y of -1. So we know both are set, and it's a nice, neat single line of code replacing double calls throughout the function. Okay, for right, we are going x-axis 1, y-axis 0. Oh, what am I doing? Y-axis 0. For down, it's this, and for left, it's this. And now, we can actually put these in the correct order. We don't have to. Oh, other way around. I need to move 3 down. So now, at least, this is 0, 1, 2, 3, and these are just wonky to make it do what we need, even though this is now up, down, left, right. One other thing we need to change is when we draw our snake head, we are still accessing the wrong xdir and ydir here, and our direction here. So this is kind of a big deal. Hey, we don't need our rectangle to be drawn anymore. And also, snakehead x and snakehead y is global. That's dangerous. These should be local. Okay. Oh, there's too many spaces. There we go. Okay, snakehead.x position minus snakehead.x direction. Same for y direction. Okay, that should solve that. And then in move down here, we reset snakehead.xdir and snakehead.ydir, and then this. Okay, instead of setting .dir, we are now going to set .dirx to dir new x and snakehead dir y to dir new y. Then all this is unnecessary because we don't need to backtrack our weird directional implementation to get the values we need. And then when we actually move our snake, we move it plus snakehead.xdir and snakehead.ydir. That was a lot of changes, so things may explode. But if we do get error messages, we deal with them one by one. Oh, I already spotted one. Forgot to do this. Snakehead colon get dir. This is new. If I call this as dot get dir, I'm calling the function inside snakehead, but it's going to need to be passed a value to have self set to. I'm doing air quotes and gesticulating with my hands to explain, even though nobody can see me. By calling this with a colon, I am invoking a self member. There's a proper name for it, but that's what I call it in my head. Essentially, I'm calling the function inside snakehead on snakehead, which means it's automatically passing self as the first parameter to the function. If it had other parameters, I would need to pass them in here, but self is passed as parameter 1 automatically. Okay, here goes. End expected at line 98 to end the function at line 29. Okay, firstly, what function is at line 29? Oh, this function. That ends that. The function needs an end. Let's just clear the screen and run it again. Line 82, draw. Perform arithmetic on a null function. Line 82. Go to line 82. Getter doesn't have a value. Now we can't in the outline see getter because it doesn't belong to the global namespace, so we need to actually find getter. For some reason this does not get a value. So xdir, find. Did I? Oh, this is all referencing. Oh yeah. This is not dir x. This is xdir. Oh, that's why. Typing mistake. There we go. Boo-doo-doo-doo-doo-doo. It's working. Would you believe I spent 10 minutes rewriting a massive thing in 100 lines of code and it didn't explode more than twice? I'm impressed with myself. Hey, you know what I just noticed? There's space down here. We can add some more lines to our, now that we're on a 7x7 grid, we can add some more down here. So right at the top of our file, grid size 19. That's too many. 18. Oh, that's nice. Okay, the spacing is a little wonk. So we need to increase our border so that it sits a little more center. So at the moment it is cell size, which is 7 divided by 2. So it's 3.5, which rounds down to 3. 5. Hey, that's perfect. Okay. We're getting there. Okay, let's give this snake some segments. They're not going to move yet. We're just going to add them. So we're going to need a global array to hold onto those segments for us, and so that they can refer to each other back and forth. So let's make a big global array called snake. Now I've explained before that this is a table, which is an object. Oop, I shouldn't put it between these two because they belong to the same thing. Let's put it below this function. Snake. So this is a table in Lua which has object properties and members, but in Lua a table can also be used as an array. So this can have arbitrary things in them, like such. And these are indexed like an array. So if I ask for snake with an index of 1, it'll give me 5. That's important to mention. It's 1 indexed. It starts at 1, not at 0. So index 1 is actually this one. There is no index 0. That's 2, that's 3, that's 4, that's 5, that's 6. Also, because Lua works on a reference based, if I go to snake index 4, it's not going to give me a pointer named Jad. It's actually going to give me whatever object Jad is. Same with, I don't know, CIA. I just keyboard bashed. Which is useful because it means we can put snakehead in our snake array as the first object. And as long as everything has the same stuff inside it, except maybe our getDirection function, as long as everything has the same stuff inside it, it's all generic and we can call the same functions on all of them. And then if we want to access snakehead directly, we can, or we can access snakehead by index. Also a nice little detail, if you put a hashtag in front of the name of a thing, this gives you the length. So in this case, hash snake would be equal to 1, 2, 3, 4, 5, 6. So the length of snake is 6. What's also handy, considering what I just explained, is that snake 6 is the last index in the array. So that's a quick way to find the end. You can actually go like this. Snake, index the length of snake, which is 6, 6. So later on, when we start adding segments to the back of our snake, we can get to the back of the snake like this. Okay, with that out of the way, what's actually going inside snake? Well, snakehead to start. Now, because it has the curly brackets, it makes it an array of one object. If I just did this, then they're the same thing. Putting braces around it means this is an array containing one object, which means we can now add more, which we should probably make a function for, so that every time we have a new segment, we can just call a function and pass it the values it needs. And these will be the values it needs. So let's just copy snakehead for a second. Let's go right to the end of our file. Maybe below move. We make a, this is all tabbed wrong. Why is this one tab in? How high does that go? Up to there. Well, no, the contents of drawer has to be, so that's where our mistake happens. These all need to be tabbed one out so that they line up to the edge. Okay, where was I? Here. Function, new segment. We'll add its parameters in a second. And then these are the things it's going to need. So I can go, let's call this segment equals, and then all the things that need to be inside segment. So X position is going to be X position. Underscores are strictly not necessary because we have our whole convention of finding the right value at the right place, but we can calculate these at runtime. It's only for snakehead that we need to know which direction it's going. The rest of them we can work out because it's just following the one in front of it. Do we need anything else? I don't think so. The rest we can just work out. Okay. So, for the sake of testing our thing, let's introduce our boot function. I've talked about this one before in the previous tutorial, but where TIC runs 60 times a second and it keeps running, boot runs once. When you run the cartridge, it'll run boot once and only once. It's your init function, and it allows you to set a bunch of stuff. So, set starting direction, I'd like to do, seeing that we're here. So, snakehead dot X direction is equal to 0. Snakehead dot Y direction is equal to -1, because we will be moving up when we start. The new X is equal to 0. The new Y is equal to -1 to match. And then here we can now go new segment. This is only for testing. Where is our snake when we start? It's at 3. But we're moving up, so we would probably want to see the snake going up before it leaves the screen. Grid size 18, so we can start this at, say, 15. Which means we can add a segment. It's 2 and 15. We can add a segment at 2 and 16. New segment. Oh, I forgot something. 2 and 17. New segment 2 and 18. 3 should be fine. The thing I forgot is we're creating a new segment, but we're not adding it to our table. So in new segment, we're creating our object, but then it just disappears. Oh, actually, we can make this local. So when we're done creating the object, we actually need to insert it on our table, which is a Lua internal thing called table.insert. Now, table.insert takes a minimum of 2 values, which is the table that we are inserting on, in this case, snake, and what we are inserting, in this case, segment. We can also pass it, this I think inserts it at the beginning, but we can also pass it the index where we want to insert it, and that index is going to be the length of snake plus 1, because we know this gives us the last index in snake, and we want to insert this after. So if our snake is, like in our example, 6 segments long, then this would tell it to insert at 7. Okay. So if all went well, we should now have a snake with a head that's probably going to shoot off in a direction and 3 segments behind it. Oh, we're not drawing it. We're not drawing it. In draw, we need to now draw. Actually, we would want to not move. We would want to draw our snake at last. So after drawing the grid, we then draw snake body, and for I in pairs snake it'll be I and V index. Hello, editor Zach here. I realized when I was coding this I didn't explain what pairs do. So a normal for loop is for something equals a value up to where it goes and by how much to end, right? But because we're dealing with a table that's an array, we can actually use this internal function from Lua called pairs to loop through all the items inside a particular array. So other coding languages call this for each, but Lua doesn't have a for each. It instead uses what's called an iterator. So for something, it'll be index and value in pairs, and then you pass it a thing. So in here we will have index is equal to whatever the first index is, and value would be equal to, in this case, the contents of that first thing, which is snakehead. It is worth mentioning that this works on everything, any table that's a key value pair, which as far as I know is all of them. So if I do index and value of snakehead, then the first index would be, I think, X position, and its value would be whatever the X position is, and it would just loop through that top down through all of them. So pairs, super handy. In some cases you can also use I pairs. Value, I think just value in I pairs, which assumes that their indexes are in order, but especially if we're doing stuff like inserting things into a table that's not necessarily in order, there might be indices in between that don't have a value. So this is kind of risky, but pairs just goes through everything within that table and lists them one by one, giving you first the index and then the value of the thing. Also, Lua allows you to pass multiple values to a function call and return multiple values, but we're not going to use that. Okay, back to what I was explaining. The index of the snake piece and the value of it too. And we're just going to, I don't know, make just a rectangle so we can see what it's doing. A rectangle takes x, y, width, height. So we need the snake segment dot x position, but we need this in grid space. So grid of that, grid for value dot y position, and then cell size wide, cell size tall, and a stupid color. Let's make it purple. Color 1. Okay. Bad argument number 2 to insert. Expected number expected got table. Did I misremember how table.insert works? Does table.insert take find table index then value? See, we all make mistake. Still explodes. Local val 924. Oh, because I forgot to actually pass this its x position and y position. Okay. So we are drawing a snake pieces, which one of is underneath our snake head. And we are artificially holding our snake head back. So it looks like it's moving into that square. Okay. Did we, let me just go look at boot. Did we create a snake segment that's below, no, 18? If we're drawing a grid of 18, is our grid function giving the correct position? Border plus the value times cell size. Oh, because the first cell is a 0. So should we minus cell size? There we go. That fixed it. I hope this video was okay to follow, because that was a lot of changes very quickly and I don't know if I explained them properly. But if there's any questions, feel free to comment and I'll do my best to explain them better. If it's not something that I can explain in comments, I'll make a short that explains it in a little bit more detail. If that's still not enough, then I'll address it in the next video. But at least we have a snake and it is showing on screen as coloring in the little squares. I think in the next one I'm going to introduce a little debug function that allows us to essentially make the game run in slow-mo so that we can investigate what's happening. Because when we start animating the rest of the snake, we need to actually see what we're doing, because this is running a little fast. But we'll deal with that then.